Dylan here with Halogen Systems, and today I'm going to show you how to establish communication with one of our Ballast Water Standard Sensors and a DO1 display. Part of this video we're also going to go into some troubleshooting steps regarding establishing communication with a sensor while you're going through some of the wiring as well. So some of the things that you're going to need is a PH1 screwdriver and a flathead screwdriver, as well as a small electronics screwdriver. So what I have right here is one of our ballast water hot tap sensors. This is a sensor designed to be installed directly into a ballast water pipe and then mate with a 2-inch FNPT connection to a valve. And then we are going to be connecting this sensor to the system via the junction box here. For instruction purposes, I'm not going to go through full cable gland installation. However, that is how you will be doing this in the field. Would be wiring your cable gland from your display to the junction box here. The first thing we're going to need to do is to open up our junction box top here so that we can get to the junction box PCB. There's 3 Phillips head screws, and there's a small O-ring gasket that goes along here, and this comes from our factory pre-wired, as you can see here. And you'll notice that we have our wiring pinouts, and this is where you will be wiring to the display. So for the purpose of this video, I'm just going to use this wiring harness here to connect to my display, and this is going to imitate basically a 4-conductor cable that you would be using on a ship. Your ship would be a 4-conductor cable with a braided wire to match to a 6 to 12 millimeter cable diameter to fully seal within this strain relief here. So we're going to wire our power into the far right connector here with the one marked with 24 VDC. Then we're going to wire our ground to GND. And these are just little push to connect terminals. You can do them with your finger or with a small screwdriver. I like doing the small screwdriver because they tend to slip quite a bit. Data A, which for me is going to be white. Data B, which is green. And then I always like to give it a little tug and make sure everything here is connected. Next, we're going to wire into our display. To wire to our display, we're going to remove the 4 cover screws here. This is just with a flathead screwdriver. Now for initial function testing, you can do a similar thing like I'm doing here, just with a wire, the sensor, and a beaker of water. Now if you are wiring onto the ship, you're going to want to knock out these, wire in your liquid tight cable gland and your cable the same way that I'm doing here, and then making sure to make that connection tight. But for instruction purposes, I'm not going to go into that too much. So we have our display faceplate here. Where we're going to be wiring right now is into the portion marked sensor here, which is going to be RS485B, RS485A, ground, and 24 volt power. I have already pre-wired into one of my terminal blocks to save some time, and these connectors can just be removed like so. And I will connect here. And then you'll want to supply 24 volt at least 1 amp power to the display on the J1 terminal here. In this case, I already have a power adapter hooked up with the terminal block, so I'm going to head and connect that here and to here. And you can hear the sensor start to power on, and we're going to take a look here and see if we have communication. And sure enough, we do with the address 125. As you can see, I am running the sensor dry right now. And this will also happen if you're doing your initial plug-in and startup. A reminder, you don't want to run the sensor dry for too long because our sensor is designed to run in water. So when you're hooking up to your ballast water system, you just want to confirm that your PLC is going to put our system into standby when the ballast water system goes into standby as well. Otherwise, our sensor is going to be running in a dry pipe continuously, and that can lead to some increased wear and tear and decrease in long-term reliability as well. So make sure that if you're going to be having the sensor dry for longer than say about 2 hours, you want to make sure to shut off power to this portion of the ballast water system. So we're starting to get some measurements here. And now you can see that we're getting an error 31. That is the error in sensor alarm. And that occurs when our sensor is oftentimes running dry. So I'm going to go ahead and show you how you want to fix that. So this is a totally normal alarm, obviously, when we're running the sensor dry. And the best way to fix that and confirm that our sensor is working well is to run the function test. So now that our sensor is running, we can pull off the cap. This cap just has a wet towel in there to keep our pH sensor dry, keep our pH sensor wetted. So to establish good water flow here, I can just give the sensor a little swirl, and then you can hear it start running again like so. And one of the ways that you can check this is just pulling it out a little bit to be able to see the water stream coming out of the sensor. Error 31 will auto clear once that condition of the sensor has been improved. And as you can see, the error 31 has now left the display screen because we have established good water flow to the sensor. And that is just a quick setup for how to connect our sensor to a ballast water system. The next thing that you would want to do is wire into the PLC using the PLC wiring here. Output 1 is chlorine, output 2 is user defined and can be PSU, pH, temperature, conductivity, or ORP. Output 3 is always temperature, and output 4 is always pH. Now this is all active, so make sure to hook up to a passive PLC. You do not need to supply power from the PLC, otherwise these outputs will not work correctly. So that is establishing communication with a ballast water hot tap standard sensor. If you guys have any questions or would like additional information, please feel free to reach out to tech@halogensys.com.